Okay, so continuing on, so I plotted this point down here. I've got a slope of -3, but I really don't want to keep going down and make my graph any larger than it already is. So I'm going to go up and back a few times because odds are it's not going down any farther. Could be. But I would always try to go up and back to keep it as much on the graph as possible. So up 3, back 1, up 3, back 1. And because this has an intercept of 2, I'm going to keep going instead of just doing my 3 points because I can pretty well guess that it's going to be somewhere up in here that it's going to hit just because of what this is and what the slope is on it. So up 3, back 1, up 3, back 1, up 3, back 1. Let me go one more time. Up 3, back 1. So obviously a little bit excessive, but, and I may not have needed all of those, but we'll have to see. All right, so then my other one is I've got an intercept at 2. And it's a negative slope, which would mean down 1, right 2. Obviously, I can tell I don't need to go this way. It's not going to intersect over there. So I'm going to go up 1, back 2, up 1, back 2, up 1, back 2. And there's my other point there. So this point is -1, 2, 3, 4, 5, 6. -6. 1, 2, 3, 4, 5.
I'm not done. Question. Is this all I write for that?
You're saying yes or no if this is the case. If it is, then you're giving this.
Okay.
Yes.
Okay. So to check it, for the sake of time, I'm just going to check it in one. Do y'all want to check it in the top or the bottom one?
Top.
Top. So 5 equals -3 times -6 minus 13. So that's positive 18 minus 13 is 5. If you were to check it in the bottom one, use the original equation to check it in. Any idea why I would want to do that?
Because you could have accidentally messed up when making the slope intercept.
Yep, I could have messed up my signs or something when I changed it, so always use the original equations to check. And we would leave everything like on this side. So when I plug the numbers in over here, I would leave them over here and make sure that it comes out to be equal to -4 if I had done that option. All right, 12. This one's not as long. Y equals 4x plus 3 and 20x minus 5y equals -15. All right, so I would first and foremost get this into slope-intercept form, so subtract 20x. So I've got -5y equals -20x minus 15. Then I need to divide by -5, so y equals 4x plus 3. Well, what do you notice?
They're the same.
They're the exact same line. So that means that this has infinitely many solutions. And I don't even need to graph it. Now, I'm looking for you to write infinitely many solutions, okay, when you do this. If it's infinitely many or no solution, you have to write that that's what it is. If it's one solution, you don't have to write, like, one solution. You just need to write what that is and it's an ordered pair. Now, if it was to happen where you end up with lines that are clearly parallel, okay, meaning that they have the same slope but a different y-intercept, then you don't even need to graph those either. You can just say no solution, and I would just say parallel lines, okay, for the sake of this section. When we get into the section 2 and 3, you will mathematically be showing what it means for there to be infinitely many solutions and no solution, but as far as graphing, you can just say parallel lines, no solution, okay, if there's any like that when you go to do your homework. Solve and classify. Solve the system, then classify it as consistent and independent, consistent and dependent, or inconsistent. So basically with these, I'm not even worried so much about you actually solving it out and graphing it because you're doing enough graphing in these problems up here. All I care about are these ones down here at the bottom of the section is that you tell me what kind of a label it would be. Consistent and independent, consistent and dependent, or inconsistent. Okay? And we'll be able to tell that just by looking at the graphs. Okay? Like the equation of the lines. So with 18, I've got 2x minus y equals 4, and x minus 2y equals negative 1. So what I want to do is I want to get these into slope-intercept form, both of them. And then I'm just going to look at them, and based on their slopes and their intercepts, I'm going to be able to tell what they are. Okay? So to get the first one by itself, how do I get y by itself in this first one?
Subtract 2x.
Yep, so negative y equals negative 2x plus 4, divided by negative 1, y equals 2x minus 4. So that's the first line. Over here on this one, what do I do for the second one?
Subtract x and then divide by negative 2.
Yep, so negative 2y equals negative x minus 1, divided by negative 2, y equals 1/2 x plus 1/2. All right, so are these the same line? Nope. Do they have the same slope? Nope. So that means that this has to be one solution. If you want to graph it and find the solution, you're more than welcome to do that, but I'm not going to make you do that. And then you would need to say consistent, and it's one solution, so independent. So this is the information that I'm looking for here on these problems. So it's slightly modified instructions. Let's see. Y equals 2x minus 1, and negative 6x plus 3y equals negative 3. All right, so the first one is already in slope-intercept form, so obviously don't need to do anything to that one, but I need to get this one down here by itself, so I'm going to add the 6x. So 3y equals 6x minus 3. Divide by 3. Y equals 2x minus 1. So what do you notice about these?
Same slope.
Yep, they have the same slope and the same y-intercept because they're the same line. So this one would be infinitely many solutions.
Consistent and dependent, right?
Yes. So infinitely many solutions, and then you would say consistent and dependent. Let's jump down 28. 5/2 x minus y equals negative 4, and 5x minus 2y equals 1/4. So top one over here, going to subtract the 5/2 x, so negative y equals negative 5/2 x minus 4. Divide by the negative, y equals 5/2 x plus 4. this one over here. I've got negative 2y is equal to negative 5x plus 1/4. Divide by negative 2. Y equals 5/2 x plus 1/8. Nope, minus 1/8. All right, so what's true about these lines?
They have the same slope.
Yep, they have the same slope but a different y-intercept, so they're parallel lines. So that means there's no solution and it's inconsistent. Any questions about any of this? We okay on graphing? I know I only did 2 of them, but okay. All right, problems then. 3, 5, 11, 17,
Okay.
No,
21,
I'll be fine.
or hold on, 19, 21. All right, so again, you only have to graph on these ones. These ones you don't need to graph.